take place much more slowly. It will take several days to do this, but we'll do it as soon as we can after launch. Here we're separating the telescope from the warm space transit bus so the telescope can get forward. We're unrolling the protective layers, protective coating. More done, then we have to pull out the sun shield to the side as well. And if you look at this and you say, isn't that complicated? You should say, yes, that's extremely complicated. Isn't that kind of risky? Yes, it's very risky. How are we going to make sure that it works? We practice. We have to do very, very many tests. The last thing that happens is the unfolding of the telescope itself. And finally there it is in its almost final shape. Of course, the James Webb Telescope is not in focus at launch because it's folded up. We learned how from the Hubble Space Telescope and the mistakes that were made, how to focus the telescope after launch. So now we do this on purpose. We've learned the mathematics, we've learned how to take the observations to calculate the focus. So this is a drawing of the telescope configuration. Here these are almost parabolic primary mirrors, small hyperbolic secondaries, and then behind it is a tertiary mirror, a third mirror, which is concave ellipsoid, and it's used for correcting the aberrations of the observatory, so it has a very wide field of view. So the focal length is already 131 meters, which would have been astounding to our prior generations of astronomers. Although, I suppose, 131 meters, they would have tried to make a lens with that focal length in the earliest days, right? But it would have still been extremely difficult. So we have 4 instruments, as before, except one of them has now slightly different capabilities. They cover the cameras and spectrographs to cover the entire wavelength range from 0.6 microns to 28 microns, which is a much longer wavelength. It's a wavelength that the human body emits very strongly, just as we're warm. So there are the 4 instruments. This one comes from the United States. This one from European Space Agency with contract to Astrium, which is an autograph near Munich. The third one comes from the mid-infrared instrument. It comes from the European Space Agency, is sponsoring a gigantic European consortium, which is actually led by Gillian Wright at the UK Advanced Technology Centre in Edinburgh, in partnership with P1360633 Jet Propulsion Lab.